Hello everyone, welcome to my channel Shah classes. My dear students, today I am going to continue the chapter of class 10 Ncert Science Electricity, and this video can be accessed by the Karnataka SSLC State Board students of class 10 and CBSE board students, and also some part of the chapter can be utilized by ICSE board students also. And particularly I can tell you one thing, whichever the state who are going to follow Ncert Science, even those state board students also can view this video and you can utilize the opportunity to learn with Shah Faisal sir. Let's begin with today's class. Children, as we have seen in the previous class, already we have discussed few important topics related to electricity. Am I right? Good. And today just we are going to continue the same thing here. Children, as I have said you about the circuit diagram, right? Circuit diagrams. Children, today I am going to show some diagram. This is very important for your upcoming board exam. So please do not miss this circuit diagrams. You can expect at least one question from this main. Okay. First is, they may ask you to draw the circuit diagram for a electric cell, or write the circuit diagram for the electric cell. Okay. An electric cell. The circuit diagram is, if they ask you to draw the circuit diagram for a cell, then you are supposed to draw in this way. So this is positive and this is negative. Always remember, this is the bigger and this is the smaller line, right? So always the bigger line denotes positive terminal and smaller line represents negative terminal. That is known as a cell. Similarly, a battery. Similarly, next circuit diagram we are going to draw a battery. So what exactly the meaning of battery? Battery is nothing but if you take more than one cell connect together, okay, आप एक से ज़्यादा cells को एक साथ connect कर रहे हैं तो उसको हम बोलते हैं battery. Okay, ನೀವು ಒಂದು cell ಇಂದ ಜಾಸ್ತಿ cells ಗೆ ಯಾವಾಗ ನೀವು ಕೂಡ್ತೀವಿ, ಯಾವಾಗ ನೀವು ಎಲ್ಲ ಒಂದಕ್ಕಿಂತ ಜಾಸ್ತಿ cells ಗೆ ಜೋಡಿಸ್ತೀವಿ, ಅದಕ್ಕೆ ನಾವೇನು ಹೇಳ್ತೀವಿ, battery ಅಂತ ಹೇಳ್ತೀವಿ. Okay, so battery is nothing but a combination of cells, that is known as battery. As we can see, this is positive, this is negative, correct? Again this is positive, this is negative, again this is positive, this is negative, like that it goes on continued. Positive, negative, this is positive, negative, like that you should not write. Remember, only if you write the beginning and the last, that is more than sufficient. So this is positive terminal and this is negative terminal. Just if you write only for the first and last, that is sufficient. Okay, that is known as battery. Now here we have the component which is called as a switch. Okay, what it is? Switch. So children, switch is also known as plug key. Switch is also known as plug key. Is this clear? Now the question arises here, what is switch? What do you mean by switch? What is switch, children? Children, this is your theory question. This is the theory question. Note, remember, they may ask you to write the function of a switch or what is switch, both are same. So what exactly the switch does here in the electric circuit? Very simple. Switch, what it does, children? A switch makes a conducting link between cell and the bulb. Switch, what it will do? Switch makes a conducting link. Switch makes a conducting link between the cell and the bulb. तो स्विच क्या कर रहा है? कंडक्टिंग लिंक बना रहा है, मतलब कि सेल और बल्ब के बीच में एक लिंक प्रोड्यूस हो रहा है. ओके, दैट इज नोन एज स्विच. The link which connects cell and the bulb, that is known as switch. Okay. Now here we have two cases in the switch. When the switch is open, when the switch is in the open case, when the switch or the plug key, when it is open, how it looks? If the switch is in the off condition, that is nothing but closed. We can call that as closed condition. Okay, when the switch is open, when the switch is closed. How the circuit symbol looks? Very simple. See children, when the switch is in the open case, you are supposed to draw like this. This is the open. If the switch is closed, then you should draw the circuit symbol like this. Just you put one dot here in the center. It means that the switch is in the closed condition. Any doubts? Is this clear? Very good. Next point. Let me come to the next point here. Okay, very simple. I hope you people are enjoying this class, right? Good children. Next is a wire joint. Next is what? A wire joint. It means when you take two wires, okay, let me to say this is one wire, let me to say this is another wire. Now I am joining these two wires at this point. Can you see this shaded region? This is known as wire joint. So this point is joint. This point is nothing but a joint, and this as well as this both are wires. Okay, these two wires we are joining together at this dot. Okay, that is known as wire joint. Got it? So this is the joint. Can you see here? This is the joint, that is wire joint. Next case, wires crossing, when the wires crossing without joining, how it looks children? See children, I hope you have seen the pipe at your home, right? I think in the basement or in the corridors you may have seen one pipe, right? One pipe should go in this direction, one more pipe it has to go in this direction. Both will not overlap. You can see one pipe will be moving in the front, another pipe will be moving from the back side. Have you seen that case? Yes. So here also the same case here. Okay. So here when the wires are joining, see here, this is my first wire, this is the front wire, this is my front wire, and this wire it has to go, but it should not cross or it should not touch this wire. So what we do like this. It means it is going back side. It looks like front, but it is going behind. So this is the circuit symbol or circuit diagram when the wires are crossing without joining. Okay, and next we have the circuit symbol or the diagram of electric bulb. So what is the symbol of electric bulb? Just if you draw like this, it is more than sufficient. This is the symbol of electric bulb. Or in some cases, but you no need to draw this diagram. Okay, like this. 1 minute. This is not circuit symbol actually. It looks like this somewhat. Can you see here? This is my positive terminal and this is my negative terminal. So this is a bulb, but you no need to draw this. Just if you draw this one is more than sufficient. So this is the circuit symbol or the circuit diagram of electric bulb. Then we call here one more topic a resistor. What it is? A resistor of resistance R. A resistor of resistance R. So what is the symbol of a resistor? Simple. See children. So this is the symbol of a resistor. You should draw like this. I hope you can see. That is the symbol of a resistor of resistance R. And next very important symbol, that is variable resistance. Remember, this is important. Variable resistance, that is also called as rheostat. Rheostat. So this is the symbol of a rheostat, children. Just draw a resistor like this and draw one arrow mark like this, that is variable resistor. Or this can also be written in this form. Just draw the resistor like this and draw the symbol like this. So this is known as variable resistance or rheostat. Got it? Got it? Very good. And then we have the next very important, we'll be using oftenly, that is voltmeter. Voltmeter. So this is the circuit symbol or the diagram of a voltmeter. And last we have ammeter. So this is a circuit diagram or the symbol of an ammeter. Okay, I hope the concept is clear for you all. So which are the circuit diagrams we do have in our syllabus, and you can expect one circuit diagram compulsorily in your upcoming board exam. I want you need to practice these all circuit diagrams. Okay, so because this is one of the very important question for your final board exam. Okay, now today we are going to continue this class with the next important topic, that is laws of resistances. Next topic is laws of resistances. Laws of resistances. So what exactly these laws of resistances? Simple. Here we have two laws. First thing is, when resistances in series, this is first law, that is law of resistances in series. Next case, resistances in parallel. Resistances in parallel, this is a second law. Okay, I hope you have understood. We have two laws. One is resistances when they are connected in series, and the other one is when the resistances are connected in parallel. Okay, now first let me discuss when the resistances in series. Resistances in series, that is also called as resistors in series. Both are one and the same, you should not forget it. Okay, resistors are in series, or when the resistors are connected in series. Okay, resistors in series. Children, here we can expect one question. What is that? Please make a note. Write the circuit diagram. Please copy down. Write the circuit diagram when the resistors are connected in series. When the resistors are connected in series. Okay, see children, this is a circuit diagram when the resistors are connected in series. This is 1 mark question. You are supposed to draw the circuit diagram like this. Let me to say, this is first resistor, this is my second resistor, this is my third resistor. Okay, please observe the diagram how I am going to draw. These are my resistors, and I am connecting to a battery source. I am connecting this to a, you can draw 2 or 3, it's up to you. And then I am going to connect to a switch, that is nothing but a plug key. I am going to represent that by a K symbol. Okay, first you have to draw this much, and then here we have to connect two things very importantly, that is ammeter and voltmeter. always remember voltmeter is connected in parallel. Parallel means one below to other. Parallel means one below to the other. That is known as parallel. Like this, one below to the other. These all are parallel lines. Okay. If you draw one below to the other, एक के नीचे एक आप अगर से draw कर रहे हैं तो उसको हम बोलते हैं parallel. So here this is my positive and this is my negative. Now I want to connect ammeter. Always ammeter is connected in series. Am I right? So here what we do, we want to connect ammeter in series. So you can erase some part of the line and you can draw like this. This is my ammeter. This is my positive terminal and this is my negative terminal. And here you have to show the flow of current. So always the current will move from positive terminal to negative terminal. So current is moving in this direction. Can you see? Current is denoted by the symbol I. So I is moving in this direction. First it goes, can you see this junction? I will call this as X and this junction I will call this as Y. So current will flows from X. It goes in this direction and again in this direction. So current is moving in this direction. I hope you can see. Current moves from X and it will reach to Y. Again here we can see we have resistors, right? So I will call this resistor as R1 and this is my R2 and this is my R3. R1, R2, R3. Then again the current will flow in this direction outside. So now current, you can see it is coming out in this direction. So this is the circuit diagram when the resistors are connected in series. I hope you have understood how the circuit symbol looks when the resistors are connected in series. Very good. Now let me discuss few important points related to this when the resistors are connected in series, which is required for us, okay, to understand as well to solve the problems related to this. Let's start. Children, still if you have not subscribed to our YouTube channel Shah Sir Classes, do subscribe it and click the bell icon so that you can find the latest updates and notifications from our end. And the offline classes for the next year batch has got started in our Evershine coaching center. So if you have any of your friends or your juniors, the one who is studying in 9th standard, now they need to enter to the 10th standard, please you can recommend them our channel as well our classes, about our classes. Okay, we have two branches in Bangalore, that is Tannery Road and Shivaji Nagar. These are the two branches we have in Bangalore. We conduct classes from class 6 to class 12. Okay, I hope you people can understand how and what we are going to explain you all. Now some important points related to this when the resistors are connected in series. First point you need to remember, that is current through each resistors or resistances both are same. Okay, current through each resistors or resistances is same. Current will remain same. As you can see, when the resistors are connected in series, you can see how much current is here, same amount of current is here, same amount of current is even here also same. Okay, the current remains same throughout all the resistors. Next point, the total voltage across the combination, will be equal to, okay, total voltage, how much voltage will be there in this, will be equal to sum of the voltage drops. As we can see here, the current is same throughout the circuit, I is same throughout the circuit, but here voltage is not same, it drops. So total voltage will be equal to V1 plus V2 plus V3. Okay, so the total voltage will be sum of the voltage drops, that is V1, V2, V3 at R1. Can you see, this is R1, this is my R2 and this is my R3. Correct, no children? R1, R2, R3. So at R1 the voltage will be V1, at R2 V2, and R3 will be V3. Okay, is this clear? Good. So as you can see, V is equals to V1 plus V2 plus V3. And next, the third case here is voltage drop across any resistor. How much voltage is dropped, I want to know. Are you getting, children? At R1 how much voltage has dropped, at R2 how much voltage has dropped, at R3 how much voltage it has dropped. I want to know exactly how much voltage has dropped. So how can you get to know how much voltage has dropped across any resistor? You can take at R1, or you can take at R2, or you can take at R3. Please remember this very important question. There are so many resistors. Can you see here? There are so many resistors. I want particularly at this resistor how much voltage has dropped. I think you people can understand. At this resistor how much voltage has dropped. At this resistor how much voltage has dropped. I want to know that. So remember, children, for that voltage drops across any resistor. वोल्टेज ड्रॉप अक्रॉस एनी रजिस्टर. कौन से भी रजिस्टर के पास कितना वोल्टेज ड्रॉप हुआ है वो हमारे को चेक करना है. तो क्या करना है, वो किसके ऊपर डिपेंड हो रहा है, ऑन व्हाट इट्स गोइंग टू डिपेंड. सो वोल्टेज ड्रॉप्स अक्रॉस एनी रजिस्टर is proportional to, that is proportional to its resistances, its resistance or resistances. Okay, it means, example, V1 is equals to IR1, V2 is equals to IR2, V3 is equals to IR3. So V1 is equals to IR1, V2 is equals to IR2, V3 is equals to IR3. Okay, so by using this condition you can check, okay, voltage drop across any resistor. Is this clear? Good. Next, point number 4, equivalent resistance. When you are going to add all the resistors, okay, so how much the total resistance will be, that is equivalent resistance. So total, what is the equivalent resistance or equivalent resistor? Okay, total equivalent resistors will be how much? That is equals to sum of the individual resistances. That is R equivalent. EQ means total. R equivalent is nothing but total. How much resistance will be there, or how much resistors will be there? Some of the individual resistances or individual resistors. Let me say resistors only, okay, because they have used that word only in your textbook, that's the reason. That is R1 plus R2 plus R3. So this is the final formula to check what is the total resistance or the total resistors when they connected in series. Okay, the total resistance will be R1 plus R2 plus R3. We have 3 means you should add all the 3, R1, R2, R3. If it is 2, you should check only R1 plus R2. Did you understood? Got my point? Very good. And next, fifth case, remember, that is equivalent resistors or resistance is larger. Equivalent resistance is larger than the largest individual resistance. I hope the concept is clear. When the resistors are connected in series, how and what exactly we should use it. Is this clear? Next case, when the resistance, that is resistor, when the resistors are connected in parallel, when the resistors are connected in parallel. See children, so make a note as like how you did in the previous case. Write the circuit diagram, copy down this question, write the circuit diagram when the resistors are connected in parallel. Write the circuit diagram when the resistors are connected in parallel. See children, you are supposed to draw the circuit diagram in this way. Draw this resistor, okay. Again draw one more resistor. I hope you can understand the diagram how I am drawing. Similarly, draw one more resistor. Draw one more resistor. Now these resistors are connected in parallel. Now I am connecting this to a battery source. To a battery source with a plug key. With a plug key. As we knows it, we have to connect in series, right? The ammeter has to connect it in series for the resistors. And then the voltmeter has to be connected in parallel. The voltmeter has to be connected in parallel. I hope you can see this. So this is my positive terminal and this is my negative terminal and this is my plug key. This is my key, let it be in off condition, and this is my ammeter. As you can see, this is positive and this is negative. Now let me draw the direction of current. Before direction of current, let me name here, this is R1, this is R2 and this is R3. And let me say this junction as X and this junction as Y. Now let me show the direction of current. Now the current is moving in this direction. Then current will reaches to the junction X and then it flows through X. Again it comes towards Y. Again you can see the current is moving through R1, R2, R3. Now the current is splitting in 3 directions. Now again the current is coming out in another 3 directions and it will comes out through this. Okay. So this is the circuit diagram when the resistors are connected in parallel. I hope the concept is clear. Good. Now let me discuss few important points related to this when the resistors are connected in parallel. Some important points let me study which is related to when the resistors are connected in parallel. Children, here that is voltage across each resistor, voltage across each resistor is same and is equal to the applied voltage. Is equal to the applied voltage. It means that voltage across each resistor is same. In this complete circuit, voltage remains same. Okay. Next point, total current. In this case, the total current will be equal to sum of the currents through the individual resistors. Is this clear? Good. It means total current will be sum of the currents of the individual resistor. As you can see, now current is passing here, right? So here we have one resistor, as we can see in the above case. Here we have one resistor, here we have one resistor. Now this is current I. Once if it passes here near R1, it becomes I1. If it is passing through R2, it becomes I2. If it is passing through R3, it becomes I3. It means here current is going to branch. Here branching of current is going to happen. So current doesn't remain same throughout the circuit. So here total current I will be equal to I1 plus I2 plus I3. Okay. And third case, that is currents through various resistors, are inversely proportional to the individual resistors. So next point, let me see, that is point number 4. That is reciprocal of equivalent resistors will be equal to sum of reciprocals of individual resistances. That is 1 by, when the resistance are equivalent resistors, 1 by Rq will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula to find when the resistors are connected in parallel. Okay. Next point, equivalent resistance means total resistor. Okay, equivalent resistance will be less than the smallest individual resistance. Equivalent resistance will be less than the smallest individual resistance. Is this clear? So in short, if I want to explain you about this, when the resistors are connected in series as well as parallel, the major difference is resistors in series and here resistors are connected in parallel. Okay, when the resistors are connected in series, as I have suggested you earlier, okay, so what is the formula, what is the current in this, what is the current remains same, am right? Correct. So how we got this, I will show you. We know that according to Ohm's law, V is equals to IR, correct? According to Ohm's law, V is equals to IR. But in this case, I is nothing but current is same. Current is nothing but I is same. Here also V is equals to IR. In this case, voltage V is same. Got it? Any doubts? Good. Now as you can see, I mean potential difference, V is nothing but potential difference is same. Here current is same. Understood? But here V is equals to V1 plus V2 plus V3. V is equals to V1 plus V2 plus V3. Then how much will be V1? V1 will be equal to IR1, correct? V2 will be equal to IR2, V3 will be equal to IR3. That's nothing but, then what is V? What is V? V is equals to V1 plus V2 plus V3, correct? So let me say this is equation 1. Let me say this is equation 1 and let me say this is equation number 2. Now what I will do, what I am going to do, I will substitute equation 1 in equation 2. In place of V, can I substitute IR? What is V? V is IR. So in place of V in equation 2, I am going to substitute IR according to equation 1. Okay, IR is equals to, what is V1? V1 is IR1, V2 is IR2, V3 is IR3. So here IR is equals to, I is common, then R1 plus R2 plus R3. So this I and this I will get cancelled. Okay, so what is left out? R, that is S means series. Okay, the equivalent resistance when they are connected in series, RS is equals to R1 plus R2 plus R3. So this is our main formula. Understood now? Is this clear? When the resistors are connected in series? Good. Now come back to when they are connected in parallel. When they are connected in parallel, similarly in this case I is equals to I1 plus I2 plus I3. Let me say this is equation 1 and this is equation 2. Now here we are taking in terms of I, correct? So equation 1 V equals IR, then I is equals to what? Keep I here as it is, shift R here. So what happens? I is equals to V by R. From this equation I will keep here as it is, R I will cross multiply down. So what happens? It becomes V by R. So I is equals to V by R. I is equals to V by R. Got it? Now what do we need? We want I1, right? So I1 is equals to V is constant, right, by R1. What is I2? V by R2. Then I3 is equals to V by R3. V by R3. Now shall we substitute here? Shall we substitute I is equals to V by R? I is equals to V by R. Now in place of I, from equation 2, in equation 2, in place of I will write V by R. I is nothing but V by R. What is I1? V by R1 plus I2 V by R2 plus I3 V by R3. Then V by R is equals to, I will take V as common factor. If I am going to take V as common, then we can see here 1 by R1 plus 1 by R2 plus 1 by R3. Now this V and this V get cancelled, then 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R3. So here net resistance is parallel, so I will write as 1 by Rp. Rp is nothing but when the resistors are connected in parallel. So the equivalent resistance is reciprocal of the individual resistors. Here equivalent resistance will be equal to sum of the resistors, correct? Here equivalent resistance means total resistance here, equivalent resistance or resistor is equals to sum of individual resistors or resistances, correct? But here equivalent resistance here is, what is the equivalent resistance here in case of parallel? Equivalent resistor or equivalent resistance will be sum of the reciprocal of individual resistors. Sum of the reciprocal of the individual resistors. I hope I have solved the derivation. Actually this is called as derivation, but you no need to derive, but you should know these important formulas. These important formulas are very, very, very important. Is this clear? I hope the concept is clear for you all. I am right? Good children. So this is what actually when the resistors are connected in series as well as in parallel. Now the question here arises one thing. Now I want to discuss some important hints. Okay, what it is means, see children, here you can get multiple types of questions. Example, now what happens if we connect the resistors in series and what happens when we connect in parallel? Okay, see children, we have seen that when the resistors are connected in series, now I am discussing about series. Okay, here when we connected in series, what happens? Suppose, okay, is it possible here in this place I am connecting bulb in this place I am connecting heater, water heater. Okay, is it possible that you can connect both together, bulb and heater together? You are passing current from here and you are passing the same current to bulb and same current to heater. Is it possible that you can connect same current to bulb and heater? ओके देखो बेटा, अभी मैं क्या बोलना चाह रहा हूँ, आपके पास एक वायर है, ये वायर से आपको एक बल्ब को कनेक्ट किए, वही वायर से उतना ही करंट आप हीटर को भी दे रहे हैं. क्या आप दे सकते हैं सेम करंट बल्ब भी यूज करेगा, सेम करंट हीटर भी यूज कर सकता है क्या? नो, बिकॉज बल्ब नीड्स लेस अमाउंट ऑफ करंट बट वाटर हीटर नीड्स मोर अमाउंट ऑफ करंट. सो वी कैन नॉट कनेक्ट बल्ब एंड हीटर टुगेदर. Correct, no children? Because this both will operate at different conditions. This requires less amount of current but this requires more amount of current. Correct, no? So that we cannot connect both of them together because both of them will operate at different conditions. At different conditions. Is this clear? I hope you people have understood the concept. Understood? So you can get this type of question. Is it possible that you can connect bulb and heater in series? That is called as if you connect adjacent with each other. ಬಾಜು ಬಾಜು ಅಗರ್ ಸೆ ಅಕ್ಕ ಪಕ್ಕದಲ್ಲಿ ಏನಾದರೂ ನೀವು ಜೋಡಿಸಿದ್ರೆ ಅದಕ್ಕೆ ನಾವೇನು ಹೇಳ್ತೀವಿ, ಸೀರೀಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆ, ಸೊ ವಿ ಕ್ಯಾನ್ ನಾಟ್ ಕನೆಕ್ಟ್ ದೆಮ್ ಇನ್ series. Now one more disadvantage is there, children. When you connect in series, what happens, you know? Example, here I have connected some device X, here I have connected some device. Here one more disadvantage is, see, suppose I have connected two things, one is X and the other one is Y. Suppose this component fails, if this component get damaged, then suddenly even this component also can damage. Remember, okay, if one component get fail, even what happens, it makes the other component also to get failed. So that is one of the reason. So we doesn't connect the things together. Different things are different things, different operating systems we cannot connect with each other. Different operating condition systems we cannot connect with each other. If we connect certain things in series, what happens, if one component does not work, so it will make the another components also to get damaged. Example, and one more thing, children, you may have seen the fairy lights. Children, this question has appeared in the exam based on this. Okay, you understood now when we connect it in series what happens. So you should know these terms and conditions because these are very important topics. How the questions can be asked we cannot assure you, but you should know the concepts. That is very important. You may have used fairy lights. Are you getting, children? Fairy lights, have you seen, children? Where we used to decorate buildings. Okay, like during festivals we use decorative lights, no? Decorative lights, yeah, those are called as fairy lights. Okay, during marriages, functions, events, we used to decorate the building or the ground, all those things, right? Those are called as fairy lights. Okay, so here we used to spend so much amount of money on that. Okay, here what happens, children, if you want to decorate that, there will be many bulbs will be connected with each other. Correct, no? Many bulbs will be there. We have spent so much time on that, so much efforts, right? So much money we have spent on that for the decoration purpose. Correct, no? Here imagine if one light gone, if one light get damaged, what happens for the entire circuit? What happens, children, if you connect in series, what happens if one bulb, any bulb, let it be this bulb gone, then suddenly what happens, it makes the other bulbs also to get failed, even all the bulbs will get damaged. So here remember, actually here we connect this type of lights in parallel condition. We connect them in a parallel condition so that if any bulb has dead, if any bulb has dead, that is dead bulb, so we can replace that, we can easily replace that with the new one without affecting the other lights, without affecting the other lights, since we are connected in parallel. Because as we can see, for this how much current will be supplied, for this same amount of current will not be supplied, for this same amount of current will not be supplied. So different current will be given for different conditions, and different bulbs are connected with different what we say is that different fuses. Okay, different fuse will be there. So by using those fuses, okay, so we can just operate that fuse. It's a very big concept, you no need to go so much in depth and detail. So, understood? So by replacing the fuse which has gone, by replacing that fuse we can change that particular bulb. So remember, in those all lights, what we do, we are going in this kind of electrical gadgets, okay, we will be connecting in parallel. Even I said your bulb, heater, these all things, how we connect, we always connect this type of devices in parallel condition, but not in series. For bulb, different current we have to supply. For heater also we have to supply different current. I hope you people can understand how exactly the things are going to work. Is this clear? So the total resistance in parallel circuit is decreased. Got it? So this will be helpful for us to work the different gadgets at different operating conditions. Is this clear? Did you understood? Okay. So this is what the basic concepts related to when the resistors are connected in series and parallel. I hope the concept is very clear to you all, right? So in this class we have discussed, what are the topics we have discussed, children? About when the resistors are connected in series as well as when the resistors are connected in parallel, how they are going to operate. So this is what we have discussed in this session. So my dear students, so I like to tell one thing before going to the next topic. We have to solve, that is heating effect of electric current. We have only one topic about heating effect of electric current and practical applications of heating effect of electric current. So this is the last topic. Once if we complete this, this is the end of this chapter, electricity. Okay, children, one important note, as I was saying to you, in our next class we are going to start, that is nothing but 2nd of May 2021, that is Sunday. This upcoming Sunday we are going to start the new session. We are going to start the new chapter, new session, new chapter of maths and science. We are going to start trigonometry, and in science we are going to start the chapter light, reflection and refraction. As you can see how we have covered how we are covering your chapter electricity and quadratic equation of maths and electricity of science. Similarly, even we are going to complete your entire syllabus right from the basics till the last, okay, from the basic to the advanced level questions, your previous year questions, expected questions, theory questions, okay, numericals, everything will be covered in our revision class. So maths and science revision 2021. In this program we are completing the chapter trigonometry and light, which is going to start the date 2nd of May 2021. If any students are who are interested to join for this session, you need to pay 50 rupees for maths and for science 40 rupees. It's only one time payment you have to do. Only one time only you have to pay this amount. You are not going to pay every day or every time. In one time amount you are going to get the complete detailed information, and even the syllabus is covered of trigonometry and light in this amount. Okay, you have to pay 50 rupees. If you want trigonometry you have to pay 50 rupees. If you want light you need to pay 40 rupees. In this amount we are going to complete your revision of both maths and science of this particular chapter. If you are finding trigonometry as difficult, then only you have to pay and you can access the class. And if you want, if any students who are watching middle of this course and who want the entire course, again for quadratic equation you have to pay 50 rupees. Then we share you the link so that you can sit and practice those things, how we are going to suggest to you all. Is this clear? So please share this information in the video. Share this information about the classes what's going to begin in our next session and the next class, so that even your other friends also get benefited towards by this. Okay, so this is a contact number. You have to pay the amount 9964257448. This is also my WhatsApp number. Okay, after you do the payment either by Phone Pay or Google Pay or Paytm, you can pay the amount 50 rupees for trigonometry and 40 rupees for light if you want those class complete revision. complete revision, then you have to pay on this number. Is this clear? And after paying, you have to take the screenshot and WhatsApp to me, and later on I will let you know what you have to do and how you can access the classes. Is this clear? Good children. Wish you all the best of luck. Do well. And one thing, our channel is completely made for free of cost. It's not like you are going to pay the amount and then only you can watch the classes of our channel. No, not at all. It's completely free of cost. You can watch any videos in our channel for free of cost. In case if you want the full chapter revision right from the basic till the advanced level, even covering your previous year questions and also expected questions, discussing all the question and answers of the textbook, everything. Okay, only for that you need to pay this amount. If not, no need to pay for the individual things what we are going to upload in our YouTube channel, Shah Sir classes. Okay, only for that purpose we have introduced, to help our community, our society, our country, people, students, everyone. Okay, this is what we have done. We are not targeting only one side peoples, we are targeting each and every student, so that everyone should get benefited towards the system, I mean towards the system what is going on, the situation what is going on. To help these things, we have introduced this concept and we are taking these classes. So please share this information with your all friends, and if you have liked our class and the video, do not forget to click the like button and comment below how was this class and what video you want to make me next. And please recommend your friends to soon. Okay, subscribe to our channel and click the bell icon so that even they can find the notification and updates from our end time to time. Thank you. In the next class I am going to continue the heating effect of electric current.